Tonight we're exploring a scenario that sounds impossible, almost like a late-night what-if whispered by someone staring at the stars. What happens if Sagittarius A, the supermassive black hole at the center of the Milky Way, suddenly disappears? You've heard its name before, maybe in a documentary, maybe in a headline, but few people realize what it truly is: the gravitational anchor of our galaxy. It shapes the motion of billions of stars. It stabilizes the spiral arms. It quietly holds the Milky Way together. And yet, we never see it directly. It sits hidden behind dust and darkness, detectable only by its influence. Now imagine that influence is gone. No explosion, no warning, no radiation, just silence, followed by the instant unraveling of our galaxy's delicate gravitational order. Orbits shift, stars scatter. The Milky Way begins to deform around a missing heart. Before we dive deeper into this cosmic what-if, a quick like or subscribe helps the channel more than you know, and hitting the bell ensures you never miss an episode. Now, let's imagine a galaxy waking to find its anchor suddenly gone. In the calm darkness of the galactic center, where stars orbit at mind-bending speeds and gas clouds swirl like cosmic storms, Sagittarius A sits silently. It exerts a gravitational influence so immense that stars tens of thousands of light-years away feel its pull. Yet if, in one instant, that supermassive black hole vanished, no trace, no remnant, its absence would ripple outward like a shockwave made of nothing. And that shockwave, paradoxically, would begin with silence. There would be no visible flash, no explosion, no dramatic flare. Gravity does not travel instantly. The change in the gravitational field would propagate outward at the speed of light. For the first 26,000 years, our distance from the galactic center, Earth would feel nothing at all. We would still orbit the same path around a black hole that no longer existed. But near the center, the stars would know immediately. The S-stars, the ultra-fast bodies that whip around Sagittarius A in tiny, blistering orbits, would suddenly be loosed from their gravitational leash. These stars rely on the central mass to curve their paths. Without it, they would fly straight outward according to their current velocity. Launched like celestial shrapnel, hundreds of massive stars, already moving at thousands of kilometers per second, would pour out of the core in every direction. A void, a literal hole in the galaxy, would form at the center. Not empty space, but a gravitational absence, a missing force that billions of stars once answered to. A collapse not inward but outward, as if the galaxy's heart had stopped beating. And the outer regions, they would soon follow. To understand how the disappearance of Sagittarius A affects the rest of the galaxy, we must imagine gravity not as a static field, but as a message that takes time to propagate. The moment the black hole vanishes, that message begins traveling outward, carried at the speed of light. Everything inside the expanding sphere of this gravitational silence would suddenly find itself free of the central pull. In the immediate vicinity, stars would behave like stones released from a slingshot. Their orbits, once curved and stable, would straighten instantly. They would rush outward along tangent paths, accelerating as they climb out of the potential well that once held them. Some would gain enough velocity to escape the galaxy entirely, becoming rogue stars cast into intergalactic darkness. Others would crash into each other. The galactic core is an incredibly dense environment. Thousands of stars crowd together in a space only a few light-years wide. Remove the controlling force that maintains their delicate balance, and these stars would begin to intersect, trajectories crossing at lethal angles. Collisions would vaporize entire suns, releasing titanic bursts of energy. Stellar atmospheres would be ripped apart. Fragments of star stuff would scatter like sparks from a grinding wheel. Farther out, spiral arms that once orbited gracefully around the center would begin to twist. The absence of the black hole would destabilize their rotation curves, causing the tightly wound arms to loosen, unravel, and warp. The galaxy would begin to stretch, not immediately visible from all angles, but measurable in the slow deformation of star paths. This gravitational whisper of nothingness would continue expanding, announcing the absence of the galactic core to stars tens of thousands of light-years away. Every star within that expanding frontier would face the same fate, a sudden freedom from the orbit it had followed for billions of years. Freedom in this case is not salvation, it is destruction. To grasp the enormity of what the Milky Way would become, we must attempt to visualize its transformation, not in abstract numbers, but in the shifting patterns of starlight themselves. At the center, once home to the densest mass of stars in the galaxy, a hollow would form. Not a black hole, just darkness. A region where gravity no longer curves space. A region where stars no longer whirl. It would resemble a wound in the galaxy's fabric, an expanding sphere of disrupted orbits, filled with chaotic motion and violent collisions. Surrounding that central void, the familiar spiral shape of the Milky Way would begin to distort. Spiral galaxies depend on a delicate balance of rotational motion and gravitational pull. Remove the anchor at the center, and the structure loses coherence. The inner spiral arms would loosen first, stretching outward like unraveling threads. Gas clouds, no longer drawn inward, would drift chaotically, disrupting the patterns of star formation. Over tens of thousands of years, the Milky Way's iconic pinwheel shape would dissolve. Stars that once circled the galaxy's core would travel in quasi-linear paths, stretching outward into the galactic halo. The bright band of the Milky Way in our night sky, our familiar cosmic river, would warp, thin, and eventually fragment into scattered clusters of stars drifting apart. From the perspective of an observer within the galaxy, the transformation would be breathtaking and terrifying. New patterns of bright arcs and broken arms would appear in the sky as stellar groups drift, collide, or disperse. Constellations would stretch like soft clay. Nebulas would shear apart. The central bulge, once a glowing sphere of densely packed light, would dim into a chaotic region of death and dispersal. The center of the galaxy would no longer be a place of gravitational dominance. It would be a hollow, a missing heart. With Sagittarius A gone, the Milky Way becomes a galaxy without choreography. Every star, every gas cloud, every orbit begins to behave according to inertia alone. And in the central regions, where orbits were once tight, fast, and deeply curved, the chaos becomes immediate and catastrophic. The first major effect is the slingshot phenomenon. Tens of thousands of stars near the galactic center moved at extreme velocities precisely because they were bound to an immense gravitational well. Without that well, they continue at those speeds, now unrestrained. They shoot outward along straight lines, carving radiant streaks through the galaxy. Some rocket into the halo, others pass straight through spiral arms, and many leave the Milky Way entirely, flung into intergalactic space as hypervelocity stars. Meanwhile, stars that once orbited in beautifully organized ellipses begin colliding. Many are traveling in intersecting paths now that the center no longer pulls them into stable lanes. Collisions between stars, once astonishingly rare, become inevitable. When two sun-sized stars collide, the energy released outshines entire clusters. Gas is ripped apart. Shockwaves ripple across light years. The core region becomes a storm of incandescent wreckage. Even stars that avoid direct collisions experience immense tidal forces as passing giants distort their outer layers. Some stars lose their atmospheres. Others are torn into elongated arcs of plasma. The space once dominated by the quiet, crushing pull of the black hole becomes instead a roiling sea of destructive motion. This frenzy of gravitational chaos spreads outward across the Milky Way. The elegant spiral structure begins to tear. Gas clouds, no longer guided by rotation toward the center, drift freely, forming odd filaments and knots. Star-forming regions collapse unpredictably. The order that defined our galaxy for billions of years unravels in a matter of millennia. Without its anchor, the Milky Way becomes a storm, a galaxy in freefall. The region near Sagittarius A, once the densest, brightest neighborhood of the galaxy, transforms into something violent and unrecognizable. With stable orbits destroyed, the stars that once circled the black hole now pour inward or fly outward unpredictably. Many plunge toward the core's former center, colliding in a frenzy of gravitational confusion. Imagine hundreds of massive old stars, red giants, blue supergiants, and tightly packed clusters, being hurled at each other at incredible speeds. It is a stellar demolition derby spanning dozens of light years. Each collision releases energy that would make a supernova blush. Massive shock waves ripple through the core, igniting gas clouds into explosive bursts of star formation. But this star formation is short-lived. The newborn stars form in unstable locations, only to be torn apart days, weeks, or centuries later. Gas clouds collapse in on themselves, only to be shredded by oncoming hypervelocity stars. For a brief window, the Milky Way becomes brighter than ever before. The combined light of countless collisions turns the center into a blazing inferno visible across the galaxy. The core glows with a chaotic brilliance, like a quasar without a black hole to feed it. But this brilliance is not sustainable. Once the wave of collisions exhausts the available matter, the core collapses inward, not toward a point, but into itself, becoming a dim, chaotic region of shredded stars, broken orbits, and drifting stellar debris. The center of the galaxy, once home to a silent titan, becomes a graveyard of annihilated suns. It is the brightest and darkest chapter of the Milky Way's undoing. As the initial explosion of chaos fades, the Milky Way enters a strange and unstable phase, a galactic rebound, where the remaining mass attempts to settle into a new equilibrium. But without Sagittarius A, the galaxy cannot regain its former structure. Stars in the inner regions, having lost their orbital cohesion, drift outward into the halo. Meanwhile, stars farther from the center, still unaware of the black hole's disappearance due to the speed of light delay, continue their original orbits until the gravitational change reaches them. When it does, entire swaths of the galaxy abruptly shift course. This creates a cascading wave of instability. The spiral arms, no longer supported by the central gravitational well, begin to unwind. Their iconic shape dissolves as stars scatter in unpredictable ways. The arms become stretched ribbons, then fragmented arcs, then diffuse smears of starlight. Gas clouds, normally guided by the gravitational geometry of the galaxy, drift chaotically. Without the pull toward the center, dense molecular clouds spread outwards, slowing star formation to a crawl. New stars form less frequently, and those that do form soon find themselves tossed into erratic orbits. The galactic bulge, once tightly packed and intensely luminous, collapses outward into a disordered sphere. It expands unevenly, producing strange, lumpy structures where stars cluster by chance rather than by gravitational design. And on the largest scales, the gravitational influence of neighboring galaxies begins to matter more. The Milky Way becomes vulnerable to external forces it once resisted. The local group's dynamics shift as our galaxy loses mass, shape, and coherence. Instead of a grand spiral, the Milky Way becomes a swollen, drifting cloud of stars. A galaxy that once had form and center, now reduced to a disordered swarm, slowly spreading across space. The rebound does not restore order. It simply marks the beginning of the Milky Way's long unraveling. As the Milky Way continues to lose the gravitational coherence that once defined it, the galaxy enters a phase of violent transformation. The disappearance of Sagittarius A doesn't simply alter the paths of stars, it fundamentally changes how matter behaves in the inner regions. The dense gas that once spiraled inward, heated by tidal forces, now collapses in unpredictable directions, piling into chaotic knots and shock fronts. In the immediate aftermath of the black hole's absence, the core briefly mimics the brilliance of a quasar. Not because a black hole is feeding, but because the sheer amount of collapsing and colliding matter superheats the region. Gas clouds slam together at hypersonic speeds, generating temperatures hotter than stellar cores. The dust and debris ignite in bursts of ultraviolet and X-ray radiation. For a few thousand years, the center of the Milky Way becomes a blazing beacon, visible from tens of millions of light-years away. This temporary brightness is not a sign of renewed stability. It is a symptom of destruction. As star formation flares and burns out, the spiral arms, once gently wound around the galactic center, stretch and distort. Without a central mass to guide them, their structure collapses. Portions of the arms break apart, others drift outward like strands unspooling from a cosmic whirlpool. Star-forming regions within the arms twist into elongated filaments before tearing entirely. Nebulas that once shone in calm, predictable patterns are twisted into storm-like spirals and thready streaks. Bright clusters of young stars are flung apart, losing their cohesion as gravitational forces grow uneven. To an observer on Earth, before our solar system drifts too far away, the night sky becomes unrecognizable. Constellations warp and stretch. The bright core of the Milky Way fades into an irregular patchwork of broken light. The galaxy is not merely changing shape, it is dissolving. The Milky Way's iconic structure, the arms, the bulge, the graceful rotation, is gone. What remains is a galaxy burning through the last flashes of its ordered existence. Far from the galactic center, the solar system exists in a quieter region of the Milky Way, but quiet does not mean safe. When the gravitational influence of Sagittarius A finally reaches us, 26,000 years after its disappearance, the Sun and its planets experience a subtle but profound shift. For billions of years, our solar system has orbited the galaxy's center in a vast, predictable curve. Suddenly, that curve straightens. The Sun is no longer bound to its ancient path. It becomes a rogue traveler, drifting into the galactic halo on a trajectory determined solely by its current velocity. Earth and every planet around the Sun goes with it. To us, the change would be invisible at first. The solar system would remain intact, its internal gravity unaffected. Seasons would behave normally. The Sun would shine the same way it always has. But slowly, over tens of thousands of years, the sky would change. The band of the Milky Way would distort into something unfamiliar. The dense star fields of the galactic plane would fade. The Sun would ascend out of the disk, carried upward like a bubble rising through cosmic water. Eventually, the night sky would become sparse. Fewer stars, more darkness. The constellations that guided humanity for millennia would stretch, break, and drift apart. As the solar system leaves the galactic plane, it enters a region with fewer gas clouds and less stellar radiation. Starbirth becomes a distant memory. The sky becomes colder, not in temperature, but in character. The universe appears emptier, wider, quieter. The Sun continues to drift, no longer part of a great spiral arm, no longer embedded in the glowing river of the Milky Way. It becomes one of countless lonely stars traveling through near-empty space. Our solar system becomes an island adrift, separated from the galaxy that once gave it shape. As the Sun drifts farther from the galactic plane, the environment around us changes drastically. Interstellar space becomes thinner, quieter, and darker. The soft glow of the Milky Way, once a luminous band across the sky, fades into a faint, broken trace. Eventually, it vanishes completely. We become wanderers in a cosmic desert. The Sun remains stable, but the sky around it becomes increasingly stark. With fewer nearby stars, the night sky loses depth. The faint light of distant galaxies, once obscured by the Milky Way's glow, becomes more visible, but the vast emptiness between those galaxies grows more apparent too. Space no longer feels like a busy neighborhood, it feels abandoned. Our solar system continues drifting outward, losing all connection to the galactic structure it once inhabited. We are no longer part of a spiral, nor a disk, nor even a halo. We become what astronomers call a rogue stellar system, cut off from gravitational neighbors, wandering aimlessly through intergalactic space. Over unimaginable spans of time, the density of stars around us becomes almost zero. The nearest suns recede until they appear as faint points, barely distinguishable from distant galaxies. The Milky Way becomes a pale smear behind us, then a memory, then nothing at all. Earth would not freeze physically. Our warmth comes from the sun, not the galaxy. But the cosmos around us becomes colder in every symbolic sense. The richness of a galaxy filled with stars is replaced by the thin emptiness between galaxies. The universe becomes a lonelier, wider place. The solar system drifts on, untethered, directionless, carrying with it the final traces of a galaxy that once held it close. As the solar system continues its aimless journey, the broader Milky Way undergoes a slow, agonizing unraveling. Without the mass of Sagittarius A binding billions of stars into coherent orbits, gravitational order dissolves. Over the next hundreds of thousands, then millions of years, the galaxy stretches into a distorted cloud of stellar remnants. Our Sun becomes part of a growing population of rogue stars, drifting without allegiance to any galactic structure. The distances between stars widen drastically. What were once neighborhoods, clusters, associations, constellations, break apart as each star follows its own path. For Earth, the separation is existential rather than physical. The solar system remains intact, but the broader environment that shaped its history is gone. The thick, star-rich regions of the galactic plane recede into the past. The Sun drifts through a vacuum so vast that even cosmic dust becomes rare. Encounters with passing stars, already improbable, become almost non-existent. Over immense timescales, gravitational nudges from nearby stars, nebulae, and the galactic tide cease entirely. The solar system experiences a kind of cosmic isolation it has never known. No more periodic influences from dense star fields, no more distant supernova lighting the sky, no more soft glow from the Milky Way's spiral arms. Eventually, we become separated not only from our former galactic neighbors, but from the galaxy itself. The Milky Way dissolves behind us into a faint haze of scattered stars. Its once magnificent structure, spiral arms, bright core, thick disk, disappears into formlessness. The Sun moves into a realm of darkness, where the nearest points of light are entire galaxies millions of light years away. We become a single star system cast into the great cosmic gulf, carrying only the memory of the galaxy that gave birth to us. Long after the initial chaos, the remnants of the Milky Way tell a tragic story. Without Sagittarius A, the galaxy can no longer maintain its structure. The gravitational bonds that once held stars together weaken over time until the entire system succumbs to entropy. The densest regions, the former bulge and central clusters, thin out into loosely connected strings of stars. Pockets of higher density remain for a while, but they eventually disperse as their constituent stars drift apart. The spiral arms disintegrate completely, becoming diffuse trails of starlight stretching across interstellar space. What was once a majestic, coherent galaxy becomes a mist, an elongated cluster of unbound stars slowly dispersing into the void. Structures that once defined the Milky Way cease to exist entirely. The galactic halo evaporates into nothing. The disk stretches beyond recognition. The star-forming regions collapse or drift apart. The intricate dance of gravitational balance ends. The remaining stars, scattered, isolated, drifting, represent the last fragments of a broken masterpiece. As they disperse, the identity of the Milky Way is lost. The galaxy cannot be recognized as a spiral or even as an irregular. It becomes a stellar diaspora, a population spreading across intergalactic space without pattern or purpose. Each star becomes an exile, carrying a faint trace of its origin, but none remain close enough to recreate the shape they once formed together. For any observers in a distant epoch, the Milky Way will appear not as a galaxy at all, but as a ghostly string of stars stretched thin across the cosmos, a reminder of what was once a grand, structured system. In the end, nothing remains but scattered light drifting in darkness. With the Milky Way dissolved and its stars flung into the vastness between galaxies, the legacy of Sagittarius A becomes unmistakably clear. A single object, dark, silent, invisible, had shaped the structure, behavior, and evolution of an entire galaxy for billions of years. Its disappearance revealed the fragility of cosmic architecture. The order we take for granted, the spiral arms, the central bulge, the coherence of star orbits, depended on a gravitational anchor we never directly saw. In its absence, the galaxy was undone. The remnants of the Milky Way form no identifiable pattern. They drift toward the outer regions of the local group, becoming faint additions to intergalactic space. The once crowded neighborhood of Andromeda, Triangulum, and countless dwarf galaxies becomes noticeably emptier as the stars of the Milky Way disperse far from their origins. The universe around them changes as well. Without a cohesive galactic mass in our region, gravitational interactions among the local group alter subtly. The absence of the Milky Way's structure leaves a gap, an unfilled space where a wealthy, vibrant galaxy once spun. On cosmic scales, the region becomes quieter, less luminous, diminished. For any future civilizations that might arise in the drifting remnants of former Milky Way star systems, the idea of a unified galaxy will be a distant myth. They will see only scattered clusters and faint associations. They will search for a center that no longer exists. They will map the cosmos and discover no spiral arms, no grand disk, no heart of stars. And if they look far enough away, they may detect a faint ancient smear of light, a stretched, torn remnant of the Milky Way's final dissolution, a signature of a galaxy undone by the vanishing of the object that once anchored all its motion. In the end, our galaxy's story becomes a lesson in the delicate balance of cosmic structure, a reminder that even the largest, grandest systems owe their stability to invisible forces, and that the vanishing of a single black hole can erase the identity of a galaxy, scattering its stars into the quiet, endless dark.